Today we're going to cover section 5 of chapter 1. This is regarding angles. The section is called measuring and constructing angles. Again, the constructing part we will do in a different lesson using compasses. The first thing when we talk about angles is what is an angle. An angle is basically two rays with common endpoints. All right? In other words, if I have a point O like this, and I pull a ray off like that, there's R. That's one ray. Now, if I pick any other ray from O going like this, and maybe call that T, we now have made an angle. Most of you will recognize this is an angle. So we have two rays with a common endpoint. Now, when you look at this, there's different ways to name this. So the names for this particular angle, there's actually a few ways to do this. The easiest way is just to start with one arrow, come into the vertex, which is the common endpoint, out the other way. And so you would say that'd be angle ROT. And I use the little angle with the arc around it to make sure you don't think it's the letter L. And then finally, the other way to do it is to go from the T and go to the O and go out the R. Either one of these is perfectly fine. Normally we do try to use the lower letter first, but they're both fine. And then there's another way to name this angle, but the easy way, if you only have two rays coming from one vertex, you could call it angle O. That's if there's only two rays from O. Right now, what happens sometimes, if you take another angle off like this, and we call this, let's call it W. If I say angle O, I don't know which of these angles I'm talking about, because there's three actually. There's the first angle here, we give it a number, and we give this a number. Kind of like we did with lines. It's a shortcut. Instead of saying ROT, we could say this is the same as angle 1, and TOW, that could be written as angle 2. So that's a shortcut for these type of angles. And then, of course, there is the large angle, ROW. So these are various ways of looking at all the angles pictured on this little diagram. You think there's, three angles. There's angle 1, 2, and then there's the combined of both. And also, that's names. This is the different parts of it. And there are other ways of looking at the parts. Over here I have a diagram from the internet. And here we can see there's other ways that you can say, well, there is a common endpoint. That's known as the vertex. And the two rays are called sides. And so this is 0 dimensions. The rays are 1 dimension. And finally, there's the interior, which is all the area inside. This is a two-dimensional shape of the area. And then if you go outside the rays, that's called the exterior, or the outside of the area. So if they ask you for the exterior, or if they say a point is on the exterior, it has to be out here. The points of the interior have to be over there. And if I did give you a little quiz, let's look at this ray again. Erase this, and if I say here's an angle A, B, C, I could ask you name the sides. And this you got to be careful. Remember, they are rays. So you start with the B, that's the common endpoint, and that'd be BA. And the second one would be BC. All right? And of course, the vertex that would just be point B. That's pretty much as far as naming the parts and showing the parts. Okay, and we're done with that. The first postulate in this section is called the protractor postulate. And the protractor postulate is kind of a building block for how to name angles in terms of their measurements. Just like we measured a segment and we divided that was a ruler postulate. We're going to do the same thing for measuring angles. So you're given a line with a point O between points A and B, then all rays from point 0, or O, can be measured from 0 degrees to 180 degrees. In other words, if I draw a line, and I'm going to do this on the other board, A, O, and B, I start here, that's 0 degrees, I keep going around, and this is my ray, I keep moving it, and depending on where I go, this measurement starts at 0, and when it ends up here, it's at 180 degrees. So somewhere in there, you're in the range between 0 and 180. And of course, when you go down here, you could start with 0 again and go up to 180, depending on which way you want to go on the 0 start. So let's go over here and show you how this works in terms of parts of angles. All right, is this good? Zoom out a little bit. Okay. Okay, once again, what I've done is I've redrawn this line with O between A and B, and I'm going to show you the types of angles as we start. Now, when you go from 0, you really don't have an angle yet. It's between, so it starts at 0, and then when you start going up, you start making an angle. Now, if you go up this far, and you haven't gone straight up yet, this angle is between 0 and halfway to 180 would be 90. So that, the first type is called acute. And that means that the measurement, and if we call this x degrees, somewhere in there, this is going to be greater than 0 and less than 90. So we'll just call x, and this is degrees. All right? And the second type, after you get through those, let's say you take it and you move it straight up. Now this angle right here, x, we typically will put a little box to indicate that this is exactly what we call perpendicular, and that would be called a right angle, acute angle, right angle, and this means your x is exactly equal to 90, right? And then the next one, you keep going along. This time we're going farther from the 0. And this angle right here is more than 90. We call that obtuse. And that means your x is greater than 90. And it has to be less than 180. Because when you get all the way down to there, then you have what we call a lot of times I'll do this. That's a straight line. And we just call it a straight angle. Talking about the angle, and this means your x is equal. So these are the 4 different types of angles in terms of the measurements. Okay? Now, more definitions. Here's a couple more definitions as far as angles are concerned. The first definition is what is an adjacent angle. Adjacent angles are angles that share a vertex, but they do not share interiors. When you show this, you would say that the angles have a common ray as a side. So let me redraw this. If you take this angle right here, A, O, B, there's one angle. If I take something from the O and come off of it like this, you can see now that this top angle and this bottom angle share this ray OB. So you would say angle AOB and angle BOC are adjacent. And they share a common ray. And if you look at it, you can see it's OB. If you look at the picture, they both, the names, they both have O in the center, naming the vertex, and they have one side that goes out to B. So the common ray is OB. All right? Now, some examples that are not adjacent, you can see directly from the actual name. If I go AOB, and I look at AOC, these look like they could be adjacent because they have a common ray right here, OC and OC. No, they don't have a common ray. OA and OA, right? But these share interiors. So AOB is right here. AOC is right here. And you see this overlapping interior. So they are not adjacent because they do share vertex and they do share interiors. You cannot share interiors and still be adjacent. Okay? Finally, we got congruent angles. This is somewhat similar.